All right, well, we've got a few people here. Let's get it started. I am Michael Strong. I am the Vice President of Sales North America for Lumos Controls, and I have with me Jonathan Yao. He is our do everything applications engineer. We are so happy to see you all here today. I know that there are many others that have notified me that they'll be logging in a little late, but I don't want to hold anybody up. I know you guys have a really busy schedule and are coming in from the East Coast to the West Coast, so don't want to hold you up here. So I'm going to share my screen and get started here. We're first going to just kind of go through. Greg Garrett. We're first going to go through our product mix. And just to refresh everyone's memory, so the lighting sensors will measure, they will talk to our controllers. These are the three controllers. This is our LLLC device that can connect to as many as 3 fixtures. This is our dual channel, so 2 0 to 10 volt channels for dimming and tuning, or for double dimming. So for like an up-down light, you could use the second dimming channel. You could MacGyver it to make it work as a double dimming device. You could also, this is our single channel, and they are both 16 amp max, actually, using the 80-20 rule. And they both have zero crossover technology, meaning that the inrush of current that is prevalent in LED drivers and LED lighting will be mitigated, and therefore will not, here we go, won't affect their lifespan, or freeze relays in place, or do other damage to devices along the path. We have our trailing edge phase dimmer. This one will take up to 1,000 watts for reverse phase dimming. It is a common piece, actually. Many other companies are using the same device. We have our own device, which is the OmniTed, 120 watts of manly power, and up to, I think, 200 plus watts. The very, Jonathan, is it up to 200 watts?
125 at 120 volts.
Okay. And then what's the 277 range?
I believe it's just 250.
250, right, there it is. Okay. All right, and so then we have our dolly controller. The dolly controller, for those of you that don't know, the dolly controller is really great for emergency battery backup solutions here in the US. Here in the US, if you have a building, especially a legacy building, that has batteries in the lights, and even some of the new retrofits are still, we're seeing it because we do a lot of submittals. We see the batteries are being specified. If that's the case, we have a solution that will automate the emergency driver, rather than having to push a button for 30 seconds once a month and turning off the lights, running around and recording the results once a year for 90 minutes. We have a solution that will automate that process, keep building owners and facility managers or companies in compliance, and will be easy to validate for any safety authority that happens to show up asking for those records. It's a great great return on investment. Simple payback periods are typically 2 years or less, because of the expense in labor. So that's our Lumos controllers. They are the ones responsible to take lighting the sensors out, readings, and make the adjustments to the lighting packages that we have across the Northern America marketplace. And here we have the lighting sensors. All of the sensors, except for these two. This is both, I guess. I take that back. This is the only sensor that is just simply an occupancy sensor, and this is mostly for high bays. It's side mount, it has the case, or center mount, depending on how you want to go about it. But for every other sensor, and that's these three sensors here, they are motion and light sensing devices. This is where the magic happens in our daylight sensing technology. And where we'll get started, you have, of course, these three devices can be used for sensing. We typically are specifying a lot of this for bathrooms and other areas that are high rack, where or a lot of objects in the way, and people are moving invisibly behind a box, but they still need the light to be on. This is a great solution, the Cyrus AM. We have it in various lenses and mounting configurations for termination, whether it's ceiling type or surface, right directly to a junction box in, say, a high ceiling like 50 feet high. That is the maximum mounting height, is 50 feet. And then, of course, one of the big changes here that we have, the ENOR E. We have updated the software in the ENOR E to act as an atomic clock, or astronomical clock. So we absolutely can tell time according to the location that we're in. So it's by zip code or by location, nationwide. And we will now be able to use this to satisfy building codes and electrical codes for those requiring astronomical clocks. Typically, you'd have to go to somebody like Intermatic or somebody else, and you could do it a whole lot cheaper using our ENOR E system and the software programming that Jonathan and our team have put together. So let's get started. Of course, we have our open ADR BMS gateways, so we can connect to the open ADR folks, meaning automatic demand response. That in the 2022 Title 24 Energy Code has become a requirement for buildings larger than 2,000 square feet. Power densities, they are requiring connections to an open ADR. So they'll connect to the utility. The utility will be able to recommend off strategies during rolling brownouts, and they will give them control. But in reality, the restaurant owners, building owners, they will get stipends from the utility companies to allow them to utilize the open ADR gateway. Our BMS gateway, one of the exciting changes that is probably coming along, and I say probably because I don't want to get too far ahead of ourselves, but we may be able to drop the second gateway relatively shortly. Right now, as it speaks, we use our Iris E to talk to the ENOR E, and this Iris E then talks to our Niagara box. It's our Jace 8000, I believe. Just off the top of my head, it's Jace 8000. So let's get to daylight harvesting and Lumos controls. As you're probably aware, I don't know how much everybody knows about daylight harvesting and why we do it. We use daylight to offset the amount of electrical or artificial light that we are powering within a facility, because they are near windows, typically showrooms, offices, conference rooms, break rooms, any place that is close to or has windows built in. Then there are going to be daylight zones, and more across the country. New York and California are already have implemented, in the West Coast, I should say, in general, Oregon, Washington, California, New York, and most of the East Coast have implemented really strong energy codes that include daylight harvesting. So we're going to reduce the amount of electric lighting, and you take advantage of the natural lighting that's coming in through the building. And there are a couple of types of daylight harvesting type controls, and we'll go through each one, and that's open loop and closed loop systems. And of course, each type works completely Well, not completely differently because they both measure light, but how they measure light and what they do with that light. In Title 24 applications, and in New York, I have seen the same, and you may have noticed this for your own area. Daylight zones of 100 are not required for 120 watts or less, and 60 watts for parking garages, or when the total glazing or opening area is 24 square feet. So if we have 24 square feet, that's, I believe, about, what is that, about 3 by 8, 4 by 6.
Yeah, that's correct.
Anyways, yep. I was trying to find an exact one, like 5 by 5, but nothing came to mind. You know, 4 by 4, 5 by 5, they were all just about there, but not quite. So, that's kind of where daylight harvesting is. That's kind of just the really high level look for really get into deep into the woods or the minutia of the subject. I recommend Energy Code ACE as a resource to get your staff and your team up to speed on energy codes that are definitely required in California. And you may know of resources outside of Energy Code ACE. They at least will give you Title 24. If you know of alternative code or code sites where people can get an education and certified at low cost or no cost, please share that in our chat, and we will, at the end of this meeting, put that together and send it out to all of the registered participants and our rep agencies across the country. And we'd love to help everybody out by giving you as many resources as possible. And that's one of the many resources that we'd love to be able to share. So the next slide, we're going to talk about closed loop daylight harvesting. Closed loop detects light falling on the sensor from both daylight, that's the sun coming in from the windows, and electric lighting, so the lighting produced by the light fixtures. And that's important to note because that's a combination of lighting. There are several factors that go into the way that we detect lighting. Typically, we're picking up a reflection of the light and not directly the sun coming in. So the floor, it hits the floor, bounces, and we're capturing the artificial light above it, above the floor, along with the daylight. That's what a closed loop system does. And then it sends out the instructions from there through our chipset and into controllers, so the controllers then react accordingly. And placement of this type of sensor, of course, is crucial. You want to take into consideration reflectances of the surfaces below, and they have to be close to the lights that we're controlling. So if you have a daylight zone and there are 4 lights in there, obviously you want your light to be in the center of those 4 lights, or at least close to the light engines, as well as near the window, so they can capture both segments relatively easily, and the combination of the two, so that we can set figures like 24-foot candle. It may be that we want to use 24-foot candle as the basis for an office space. And so in order for us to do that, we set the lux accordingly. And I don't know if you guys are aware of this, but you can lux the foot candle. You can set your foot candle at 24-foot candle and see the lux reading. And so you would, in our software, this is where you would set your lux by simply doing the conversion, and or knowing that conversion ahead of time. And for reference sake, and I'll hand this out at the end of this, if you don't already have it, we have, if I can find it right quick, and I know it's on my desktop because I downloaded it today for this meeting. So I was a little bit ahead of schedule. So if you don't already get yourself a copy of the IES foot candle recommendations. If you're not using this for your own internal quoting, this is the illumination engineering standard, and it has saved countless man hours of trying to figure out what lighting to use. You just simply take advantage of the metrics here. So for example, in our case here, that we have lobbies and reception areas, and they give you a nice range of where those foot candle measurements should be. And that makes it simpler for us to roll out daylight harvesting methods. So, obviously, if you have built a lighting package to be 30-foot candle, that's going to be the maximum output. So even with daylight, you might get an extra 20-foot candle, but we would never be able to get higher than what the daylight and the natural light would produce together. So keep that in mind when looking at this, but we will hand this out if you don't already have it. If you need that, don't hesitate to ask. Also, main advantages of using a closed loop photo sensor are the accuracy of light reading and the ease of configuration, right? Because we're just measuring both, and we don't have to separate the two. And you'll see where the difference lies here in just a second. But let's look at some of the disadvantages. So the main advantages are, ease and accuracy, because we're going to read both artificial and electrical lighting, and then we're going to configure average foot candle readings and making the lights react to an average of 20-foot candle, whether it's sunny or it's nighttime. Closed loop disadvantages. A separate sensor has to be used, of course. We know that. It has to be in the daylight zone. In California, we are actually required to not just have a daylight zone, but we have a secondary daylight zone as well that we have to read from. So we have two sensors. I would love to just say that we could get away with one and read it further back in the array, but the actual requirements, and if an inspector really cares to enforce, they do require two separate photo cells or two separate light sensors. Altering the color and reflectance of the surface below the sensor can impact the light level measured by the sensor. Now, for most of us, that's an engineering and architectural design. That's nothing to do with us as electricians or electrical distributors or even as a manufacturer. But knowing that the lack of reflectance coming from a floor, let's say, that is charcoal or black or gray, compared to, say, a white marble floor, knowing the difference between the two helps us in designing not only our lighting, because a lot of what lighting is based on is reflectance. So if the sensor is located above a work surface, items placed on that surface impact the light level in a room. I think that goes without saying. All of this here is kind of a no-brainer, but these are some of the disadvantages to a closed loop system. But it is by far the most popular form and one that we can easily implement. The next one is open loop daylight harvesting. Our software is capable of handling open loop daylight harvesting. I would recommend this, if you're going to use this one, to use our Cyrus F, and make sure that you angle the Cyrus F to the window, because the difference between closed loop and open loop is that open loop only measures the amount of daylight coming in, and it throws the calibration of the daylight programming off if you use artificial and electric natural lighting in its calculations. So you want to make sure that it's pointed away from all artificial lighting and that only the natural lighting is measured. So it's critical that they measure only the natural light and not an artificial light component. And the sensor needs to be in the space where the fixtures are located, but aimed only to the outside. So my recommendation, of course, on this is that if you're near daylight zones, it's in front of the window, or it's in front of the fixtures near the window, with no fixtures forward or near the window, or it's not in between fixtures and the window. Okay, so, or it should be in between the fixture and the window. How's that? There should be no fixtures in front of it, blocking it from the window. How's that? Because again, it throws the calculations off. The obvious disadvantages to open loop is the complexity of programming. Now, where open loop is great is places like a warehouse where it has a lot of skylights. And what we would do is we would place a photo sensor at the top end of the where the lights are. We would point the photo sensor directly at the skylights, and we put this above the lights naturally so that no artificial lights, other than perhaps some small reflectance, but if you put it on top of the light, the chances for reflectance are slim. And we pointed directly at the skylight. Anyways, seasonal variations in the angle of the sun will create differences in light level sense. So it's kind of rough unless you have an automated, you have an astronomical clock and a motor moving your open loop sensor. That's going to be rough to get an accurate assessment. And sensors placed inside the space through when you put tinted windows or or blue filters or anything of that nature up, you're going to change the dynamics of the read. So you see the two types. There's also custom types that are not necessarily wrong and can be used. We offer a third method. Okay, so there are multiple methods. One of them, we offer the 2 plus a custom version, so we can actually change that. Now, since Jonathan is our primary applications engineer, I'm going to give him a chance to talk a little bit about the application when we get to that point. But we integrate daylight harvesting as part of our functional energy efficiency optimization. When we see it as part of the plan, we will obviously comply with code enforcement or code compliance. All of our, or most of our sensors that we will recommend or specify are going to have dual sensing. So that and I mean dual sensing in terms of occupancy and daylight. You do not need a separate daylight sensor in order to have occupancy and daylight in an area. And through our software interface, you can choose which specific method you want to use. You can use open, closed, and or custom. You can make it a custom variation of the two. We make it simple. We continuously monitor ambient light conditions and make real-time adjustments, as you would expect. Integration with other systems. We also can integrate with other building management systems. As I showed you earlier, we are constantly evolving and trying to make that as simple and as robust as possible. And through our software interface, as I said before, you can choose which open, closed, or custom. All right, if you choose the open loop method, 19 lux to 512 lux is the open loop default min and max values. So since Jonathan has set that most often, I'll let him talk a little bit about what his experiences are real world compared to, say, and he and I had a conversation earlier in reference to this. We talked about, say, conference areas and even general open office areas where the IES is saying, well, we should have 50 to 100 foot candle. And they say those things because they want optimum efficiency, both in energy, but also in output, in production, and people's overall mental health. There are multiple reasons for 50 to 100 foot candle. And if you are out and working with customers that have not yet upgraded, and you have your light meter with you, and you are taking readings as you're going along, that is a great way to use advanced financial metrics in order to change the perspective of the facilities manager and the CFO that's going to be looking at your project. by suggesting that because we hit the IES and they're let's say you find that they're at 20-foot candle, and we know that in general and private offices or in open office areas that should actually be 50-foot candle for the most efficient method. We can say with in all seriousness that a 2% efficiency improvement is possible. A CFO will know immediately what that means, and that's what we consider a non-utility financial benefit. Anyways, that's that. Jonathan, I'll take it away on the software portion of this.
Okay. Yeah. So how our system works is when you add your controls into a group, for example, the primary daylight zone. We're still looking at your screen, by the way, Michael.
Yeah, I'm going to get you support, my friend. I'm pulling up the that little ditty that I showed you.
Yeah, when you add one of our controllers into a primary daylight zone, for instance, you can set the lux level that you want it to read in a closed or open loop setting. For an open loop setting, you'll be able to enter 2 lux values, 1 lux value when the lights are all the way on to 100%, another lux value when it's off at 0, and the light will respond to change the intensity depending on how much lux level that sensor reads. It is a linear graph, so for instance, if the lux is right in the middle, the intensity will be at 50%, for instance, for an open loop case. For a closed loop, there's a couple of ways to set closed loop settings. You can either enter a set lux level value. You can measure your lux levels using a meter, and then you can set the light to maintain this lux level at all times. And those are kind of how you set either open loop or closed loop settings. You are able to, because of all of our Cyrus AP devices can do motion sensing and daylight sensing. You can have one sensor do both at the same time. So when no one is in the room, the lights will still stay off, even though there is daylight sensing. And only when someone enters the room or the area will the lights turn on, and then the daylight sensor will either dim the lights or increase the light intensity. We do have a couple of other settings for daylight sensors, such as the interval, where the amount of time between the measurements are taken, the lux levels are taken, so that your light levels aren't changing so much. You can set it for 10 seconds, 10 minutes, an hour, however you want it. And we also have a fade time setting on there as well. So if you want a slower fade time, you'll be able to set that. For our motion sensors and daylight sensors, we have something called a manual override, so that if someone does want to increase the light level, they'll be able to do so, and the sensors won't immediately turn it to a different setting. So that is what manual override is. You can set it for the default is 10 seconds for motion sensors or 30 minutes for daylight sensing, but you can increase that value however much you want. And yeah, that's kind of how our daylight sensing works for all of our products. Again, you have the option to turn motion sensing or daylight sensing on and off depending on what you need, even though it is the same device. And of course, since all of our devices are Bluetooth enabled, you do not have to wire these motion sensors or daylight sensors to the controllers. They just need AC power, and that's all you can need.
Mm-hmm. Very similar to Pinocchio, no strings to tie them down. All right. I think that brings us to the to a point where we will just kind of go through. We have a ton of new installations. We have some really great case studies. Stay connected with us. We let me minimize that. We're at YouTube. We have our YouTube channel. We have our Facebook and in-book LinkedIn. Oh boy, LinkedIn, Instagram. Stay connected with us. We can't wait to connect with you and help specify your next job. We have, by the way, if you haven't taken a look recently, we have a ton of new resources, including Bluebeam tool chests, so that you can download. We use Bluebeam regularly as our specification tool. We also have for engineering and architectural firms that you're working with, or that you are, if you are one, and you would like to specify our products and make it simple. Here are our CAD downloads, and here's our specification guide. This will make specifying Lumos controls easier than ever, and it's already a simple. Most of the times when we look at the controls schedule, it is a convoluted amalgam of Cat5 cabling and other low voltage wiring between devices. That reminds me that my brother was a communications or a Cat5 cabling expert. That's what he did for a living. He put servers and communications gear in across many high rises, and that is a complex and expensive proposition, especially in terms of a retrofit. Now, when you do it as part of a new build or new construction, it's still expensive, and much more expensive than using our Bluetooth mesh network system. And one of the great advantages of working with us at Lumos Controls is we are the master of 0 to 10 volt and Dolly interfacing, and you can interchange the two without having to change logins or change software or change devices. You can phase dim, Dolly control, emergency lighting. You can use all the functionality of the most current Dolly interfaces and intelligence, along with the intelligence of our Bluetooth mesh and 0 to 10 volt dimming profiles. So it's a really great time to get involved and to work with Lumos Controls. For those of you who are distributors and our rep agencies, we thank you, and we have been working hard behind the scenes to make you guys more money and help to make that process really simple. If you are a distributor and you'd like to be able to specify very quickly, our quick ship products, which we guarantee to have in stock. That would be just to go take you back really quickly. That would be things like the AF10 and this room controller, the OmniTed, these two sensors, this switch. We'll have those in stock, ready to ship next day. Use our BOM generator. What it does is it takes amps controlled, number of fixtures in the size of the room, and then spits out the needed controls to automate the lighting. To automate the lighting in your building or your application. So you can simply type in a few things, including the size of the room, the amps controlled, and produce a bill of sale right from here. If you're a distributor, this is a fantastic way to automate the submittal process, rather than having to send off for a submittal, waiting several days for a response. Our goal is, just so you know, if you don't know, is 2 business days. Sometimes we get swamped and we see 3 business day, 4 business day. But we're always there with you. We do not allow it to get too far behind, and we do not want to turn away anybody. We'll help you if you need a submittal built. But we also wanted to provide you with tools to make that process quick and easy, because really it's all about satisfying your customers in front of you. If your customers need it today, we've got a way for you to create the submittal and get it out to them today. You do not need to wait. So anything else, Jonathan, that I've missed?
I think that's all. We can talk about next time's
Next time.
webinar.
Well, without giving away too much, a friend of mine who has been in this business, been in the energy reduction and so lighting and controls for as old as Noah's Ark, Mark Jewell. He is a well-known best-selling author. He will be on the 9th of March with us. We will be talking about advanced financial metrics, how to use them in lighting and controls. And then the following, so that's meeting or episode 6. Episode 7 will be Randy Lucas and the 179D. Tell your friends, these are going to be really exciting, great ways to envision more deals. If you are working with customers in large projects and you want to find ways to entice them to take your bid over someone else's, the best way to do that is to have inventive and creative financial metrics that resonate with your clients. And I can tell you this from experience and from the thousands and thousands of people that he has helped and blessed with his experience. Mark Jewell can really help you with that. And Randy Lucas, the next week, right afterwards, he is a 179 guru, 179D guru. That is the new tax incentive for energy efficiency projects, which changes the old 179D. If any of you are familiar with that, prior to 2023, that tax incentive was about $1 a square foot. And we are now looking at up to $5 a square foot for energy efficiency projects for your customer, for your end users. So building owners, if they have 1 million square feet of property and they have a $300,000 lighting project, add controls for another 100,000. That's a $400,000 job, but 1 million square feet is $5 million, up to $5 million, folks, in tax incentives. And at a 21% tax rate, well, you can do the math. That's $1.1 million. Don't get left behind. Use the 179D. I'm telling you, it is a home run for your customers. But use it under guidance. Get a tax accountant. Get somebody like Randy Lucas, whose engineers will use ASHRAE 90.1 to validate your savings, and will help to get your end users the maximum return on in their tax incentive. So thanks everybody for coming, and we really appreciate you and hope that we can help you in the months to come. Let us know if there's anything at all we can do in our presentations. Our weekly or every 3 weeks, we'll have another episode of Getting to Know Lumos. So thanks so much for joining us today.